Okay, we have two concepts that we're going to talk about today that have to do with index laws, and they are the zero index and the power of a power. Now when we talk about, and we're going to talk about power of a power first. When we talk about power of a power, it's the example of something that has a power inside the brackets and then a power outside. So let's say we had, for example, 5 cubed to the 4th. Okay, now if I were to expand that, this would be 5 cubed times 5 cubed times 5 cubed times 5 cubed, which means 5 cubed to the 4th. 1, 2, 3, 4. And if we were to simplify that further, you know how to do these. The multiplying exponents, multiplying expressions with the same base. What do we do with the exponents? We add them together. 3 plus 3 is 6, plus 3 is 9, plus 3 is 12. Gives me 5 to the 12th. Okay? Let's use another example. Let's say we had 6 squared cubed. That would give me 6 squared, and there are 3 of them, times 6 squared times 6 squared, because there are 3. And again, what do? We add the exponents. We get 2 plus 2 is 4 plus 2 is 6. So we get 6 to the 6th. Now you should recognize here a pattern. What do you notice about this in comparison to this, skipping the middle part, or this in comparison to this? You should notice that in this situation we multiply the two exponents together. Not to be confused with when we add them. This is a different situation where we have brackets with powers on both the inside and the outside. So our rule that we have is x to the m to the power of n is equal to x to the mn. That is the rule that we develop. Now, let's use a couple of examples without the expanded part in the middle. See if you can do these. 2 cubed to the 5th is equal to what? How do we do it? We multiply those two exponents together and we get 2 to the 3 times 5 is 15. What if we expand this a little bit and make it a little more challenging? How about if we had 5 squared to the 4th times, 5 cubed squared? That looks a little bit complicated, but it's really not. Let's do each of these one at a time. Here we would multiply our two exponents together and we get 5 to the 8th. What would we do here? Same thing, times 5 to the 3 times 2 is 6. Now we're back to our original index law for multiplication. The bases are the same. What do we do with the exponents? We add them together and we get 5 to the 14th. Now, that is power of a power. Now the zero index is a completely different idea. It's all related to the same theory, but in some ways the zero index is one of the simplest index laws that there is. But before I get into showing what the rule actually is, I want to give you a process here and see if this makes some sense to you. Okay, so let's start with 3 cubed. Now 3 cubed means 3 times itself, 3 times, so we get 3 times 3 is 9, times 3 is 27. It's 27. Now what if I reduce that by 1 and I make it 3 squared? Well, 3 times 3 is 9. Or if I did 3 to the 1st, which is just 3. Now, what have we done here if we're following this process? Because my next question is, what is 3 to the power of 0? In order to think about that, think about this. What did I do to go from here to here? I divided by 3. From here to here, I divided by 3. So from here to here, what would I do? Yes, same thing, divide by 3. And what do I get? I get 3 to the 0 equals 1. Because 3 divided by 3 is 1. Let's use another example, same exact idea. Let's use 2. 2 cubed, and we could use bigger numbers than cubed, but we'll try and keep it simple here. 2 cubed is 8. 2 squared is 4. 2 to the first is 2. And 2 to the 0 equals what? Well, let's think about our process one more time. What's happened here? We divided by 2, because we've got 2 as a base. Go from 4 to 2, again we've divided by 2, because we have 2 as a base. So what would we do to go here? We would divide by 2 again, we would find out that 2 to the 0 is equal to 1. Notice the similarity here. So the rule that we developed, the zero index rule, is this one. X to the 0, any base except 0. We can't have 0 to the 0, that's a bigger problem, which we could talk about some of the time. But x to the 0 is equal to 1. Okay? Anything other than 0 to the power of 0 is just 1. Now let's use a couple of examples. By the way, these examples all involve numbers, but the same is true if we have a pronumeral. If I had x to the 0, that would be 1. If I had z to the 0, that would be 1. So let's use some examples. If I have 4 to the 0 times 8, what does that give me? Well, 4 to the 0 is what? It's 1. Times 8 is 8. 1 times 8 is 8. What if I said instead 4 to the 0 times 8 to the 0? Well, I have 1 here. 4 to the 0 is 1. 8 to the 0 is also 1. 1 times 1 is 1. Now, how about if I did this problem? Let's say I had x to the 0. We've already said that equals 1. What if I had 3x to the 0? Now this is where it gets a little bit complicated, because remember the 0 only applies to the x. So x to the 0, and we do indices before we do multiplication. X to the 0 is 1, times 3 is 3. Now very, very similar problem. How about this? Now how is this different? Clearly it has brackets. But the difference is, the brackets tell me what? Remember, I do brackets first, and then indices, and then multiplication and division. So my brackets tell me that I need to do what's in the brackets first, multiply that. Whatever it is, I raise it to the power of 0. What do I get? I get 1. Again, this is my law. X, unless x is 0, x to the 0 is equal to 1. And that is 0 power and power of a power.